Hello, class. I'm getting ready to do a Zoom video recording for section 6.1, normal distributions, and I'm in the workbook on page 138 of your workbook. And just so you know, I've sent out an email. There is an extra sheet that I'm going to make use of with this lesson. And let me just show you what it looks like. And it'll say something like extra notice, extra sheet to print out. This is in your, I believe it's your module 8, right, for your test 3 lecture material. And it looks kind of like this. So this is an extra sheet we'll be using. That's not in your workbook that we'll be making use of, okay? Okay, so it's lots of vocabulary that we're going to go over first off, okay? So the first couple pages, well, the first page I'm reading through some material, and then the second page I'll be adding to that. But the first 3 pages are reading. Then we'll work out one little mini problem on the 4th page, and then we'll get to the nut and bolt of this lecture. There's like 2 main lessons that I have to teach you. So where you're finding the probabilities of areas underneath curves. And then the second lesson is where we're kind of going the other direction, where they give you the probability, they give you the area underneath the curve, and then you have to find the z value. Okay. All right. So we'll start off saying that, many continuous variables have distributions that are bell-shaped and are called approximately normal distributed variables. So the theoretical curve called the bell curve, where the Gaussian distribution can be used to study many variables that are not normally distributed but are approximately normal. Okay, and then here's the equation, the math equation for the normal distribution. Okay, so when we work our problems, we have permission to use the TI-84 graphing calculator. And we're also going to be teaching you how to use the table. So one other thing that you'll need besides that extra sheet, at the very beginning of your workbook, you have like important formulas and you have these lists of tables. So you do want to get those standard normal tables out. So I'm looking for mine. And unfortunately, they don't have page numbers on them, but this one's called Table E, the standard normal distribution, and it's 2 sheets. One of them has a list of the negative z values, and the other one has the list of the positive z values. And so I'm required to show you both how to calculate these problems using the table, and then also how to find the answers using the calculator. And when you do your homework, you want to read the directions on your homework, because some problems they'll be asking you to use the TI-84, and other problems they'll be asking you to use a table. So you want to follow the directions. And then the same thing on your, when it comes actual to the tests, I will work problems 2 ways, showing you with the table and then showing you on the calculator. But on the test, I don't expect you to do it 2 ways, but I am testing for both. So some problems I'll ask you for the table, and some problems I'll ask you for the graphing calculator. And so you just want to be able to follow directions for that. Okay. Um, and in this formula here, they give you the value of E, which is a transcendental number. And if you've taken college algebra already, if you have to take college algebra as well, you work with E on some of your logs, natural logs, and exponential growths and things like that. Pi is, pi is 22 divided by 7, the never ending long division problem, right? And they approximate it to 3.14, okay? And so we have the mu population mean and sigma population standard deviation. And in these problems for section 6.1, you'll see your teacher writing mu is 0 and sigma is 1 a lot in this section. When we do 6.2, which is applications and story problems, then you will be told a different value assigned for mu and sigma. And then it's our job to like run it through a formula and to like transform it or standardize it. Okay. So the shape and position of the normal distribution curve depends on 2 parameters. They're the mean and the standard deviation. Each normally distributed variable has its own normal distribution curve, which depends on the values of the variable's mean and standard deviation. Okay, and so they have some pictures here of that, just that you look at that. So here they say you have the same means, but different standard deviations. Here you have different means, but the same standard deviations. Okay. So nothing to add to that page, 138. Okay, then on page 139, this is page 139. So they have normal distribution properties. All right, so the normal distribution curve is bell-shaped. The mean, the medium, and the mode are equal and located at the center of the distribution. That's why they have this written like that. So the 3M's are the same when you have this bell-shaped distribution. So maybe all the means are 5, or maybe they're all 8. Okay. The normal distribution curve is unimodo, that has only one mode. Okay. The curve is symmetrical about the mean. And some of the problems we'll be doing in section 6.2, the applications, we'll be making use of that. In the problems, you'll say, oh, because it's symmetrical, symmetry, then you can assume that, you know, the z value is like the absolute value of that, or like the opposite. Like if one z value is -2, then the other z value would be +2. And you got that similarity because there's symmetry. So we'll make use of that in some of our problems in 6.2. So which is equivalent to saying that it is that its shape is the same on both sides of a vertical line passing through the center. So I have a symmetry there. And then they say the curve is continuous. For example, there are no gaps or holes. For each value of x, there is a corresponding value of y. The curve never touches the x-axis. So theoretically, no matter how far in either direction the curve extends, it never actually meets the x-axis, but it gets increasingly close. So a lot of times when we draw it, they don't, they don't want you to draw these touching. They want you to like make it very close approaching, but like not actually touching is kind of what they're saying there, what they prefer. The total area under the normal curve distribution curve is 1 or 100%. Okay. So the whole area underneath the curve is 1, or if it's a percentage, 100%. The other thing is, a lot of times you'll have your teacher draw this mu. Let's say mu is 0. A lot of times I'll be drawing this sigma is 1 in this section. That's the value. This is called infinity, positive infinity. This over here is called negative infinity, shaded forever in the negative direction. And to type those in as values, like as upper bounds, like this would be considered like an upper bound and a lower bound. This is equivalent to a large number, and they recommend in the ebook, when you read your ebook, a 10,000. If you don't want to use 10,000 in the ebook, they also use this 1e to the 99, because this is like scientific notation. This is kind of like 1 times 10 to the 99th power. So this is a big number, like 99 zeros. Okay. So to get this e though, you have to use the second button on your calculator, and then the comma. If you look at the comma key, you'll see that EE there. Okay. So you see the comma right here. See that EE? So this is 1 and then the second value, and then the comma. See how that's blue? See that? And now it doesn't type EE, like it just says E and then 99. So I don't know why, it should really say EE. I don't, it kind of throws of someone else off, but but they're the same here, okay? And so that's how you would type that. And then on the negative side, you could type in negative 10,000 or negative 1 e to the 99. Okay, so again, you would make use of the second and then the comma key. Okay, all right. Okay, and then another formula that we'll be making use of, and let me just double check this. Let's see. Yes, for the areas underneath the curve. Another form will be using a command, a TI-84 command to find the area underneath the curve. TI-84 command for finding areas, which are known as also probabilities. So they say like find the probability, capital P. They're also talking about areas, areas under curves. Standard normal curves. So we'll be making use of this, the second, and then the vars. So you're already familiar with the vars from 5.3, right? Second vars, right? And where we use the math for option A and then the apps. Remember that? Okay, well, we're also going to use second vars to pull up this command. Number 2, normal CDF, and then lower bound, upper bound, mu, and sigma. So lower bound, I'll write LB and UB for upper bound, mu, and sigma. Okay. So you know how your teacher on your test, I want you to write the command and then the substitution. So that would be your command, and then we would substitute these with numbers. And this is called the normal cumulative distribution function. The normal cumulative distribution function. Okay. Now, when you review your videos, it might be that your videos might show you how to do these longhand, maybe longhand by hand. It might show you some of that, and but we we're allowed to use the calculator TI-84 and also the tables. Okay. So just keep that in mind. And then it says that the area underneath the normal curve that lies within, so they have here, let me make this larger so you can see, lies within 1 standard deviation of the mean is approximately 68%. So the area underneath the normal curve that lies within 2 standard deviations of the mean is approximately 95%. And the area underneath the normal curve that lies within 3 standard deviations of the mean is approximately 99.7%. So they have a nice picture of that here. And so you're familiar with that. The idea in chapter 3, we used x is equal to x bar, mean, plus or minus k times s for standard deviation. So here they're using mu instead of x bar. And then here's your k, like this is a k is 2 here. Here K is 2. Here K is 1. Here K is 3. And then they're not using S for standard deviation, they're using sigma. So here they're using mu and they're using sigma. Mu and sigma. Okay. And again, this is bell shaped. Okay. And I'm just going to put here, recall from chapter 3. How we made use of X equals, so X was like our data value equals the mean plus or minus K times S for standard deviation. So now in chapter 5 and chapter 6, X is equal to mu plus or minus K times sigma. Okay. All right. So I didn't mean to write over that. Okay. Okay, let's see. Okay, the next page, let's see. Have I think one long sentence to write on this next page. Standard normal distribution. So since each normally distributed variable has its own mean and standard deviation, the shape and the location of these curves will vary. So in practical applications, one would have to have a table of areas under the curve for each value. So to simplify this, statisticians use the standard normal distribution. So this is like your standard normal distribution tables that you want to have out. Okay. And with these tables, you want to notice here, and we can write this comment down. Let me get this note. I'm gonna write this comment down from this sheet. I have a copy of this PDF of this in your module 8. And the thing is that it's yellow though. So I think if you print it, I think if you print it, it might come out yellow unless you tell your printer to print it in black and white. But this is, different book reps give us different tables. And I like this table because it's got these values at the top and also at the bottom. See that? And then the Z's, see how they also have them on the side. So this is like one of my favorite tables. And then it also has this little notation, which I'll go ahead and write on one side of yours. So it doesn't matter if you put it on the negative side or the positive side, doesn't matter. But these notations are helpful. It says that this table represents cumulative area under the standard normal curve that is to the left of a z-score. And you can see on your paper, it's really light, but you can see how this is like shaded here. This area here. And it's, so all these areas are reflective of areas to the left of a z value. And this is z. This is a z value right here. This is mu equals 0, but this is your z value. Okay. Um, the other thing to note is that the z-score is recorded to the hundredths place. Hundredths place value. And you can see that here. If you see this z here and see this is hundredths place, see that? So all the z's are recorded to the hundredths place, tenths, hundredths. Whereas the areas, these are all areas. These are areas under the curve. The area is recorded to the 10,000ths place. See, tens, hundreds, thousands, 10,000ths, tens, hundreds, thousands, 10,000ths. So when you use a table, that's already kind of set up that way. Thousands place, 10,000ths place for area, 10,000ths place, and hundreds for z-score. But when you use your calculator commands, they have more decimal values, so you have to remember to round to the appropriate place value. So that's why I'm writing that down, so you can remember that. And even on the other chart that has the negative z value, they have this, see here? See, this is shaded this way. Okay, and this is your z value. This is area to the left, area to the left of the curve. Okay. So all these are areas to the left of the curve. That's important. Okay. So the standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. That's why I always write that in there. And then this is related to the 68, 95, 99% rule. I mentioned that. From the empirical rule, right? So I don't know if I wrote that on this side or not, but um, this is the empirical rule. I think I didn't mention, I don't think I mentioned that, but, and I didn't write it either, but yeah, that's, remember from chapter 3, empirical. It's on page 139. And then they're talking about how we're standardizing. Here's a normal distribution and the standard normal distribution. So we're going to standardize that. Okay. And so I'm going to put a comment here that I'm going to write this comment here. This is a good comment. I think I'm sure got this from the ebook probably, but this is the area under the standard normal. Distribution curve can be thought of as a probability or as a proportion of the population with a given characteristic. So the probability of choosing a z-value at random is the same as the area under the standard normal curve. So I'm going to emphasize here mu is 0 and sigma is 1. Okay, so you can pause the video if you're still writing that. Okay, but I'm gonna go ahead and continue. See. Okay, so then you have another chart here. Probability of cases in portions of the curve. Standard deviations from the mean. Cumulative percentage. Z-scores. It says recall Z-scores. Recall Z-scores from chapter 3. Z-scores are used when dealing with standard normal distributions. And so then they give you the definition, Z-value, the standard value, or Z-score. So the Z-value is the number of standard deviations that a particularly X value is away from the mean. And the formula for finding Z is, and we saw this before in our chapter 3 test. So this is Z is equal to our data value minus our mean divided by the standard deviation. And so Z is equal to the data value X minus the mean. So notice here how they're not, they were using X bar in chapter 3 from the mean. And now they're using mu divided by sigma. And remember, they were using S in chapter 3 for standard deviation. Now they're using sigma. Okay, and also in chapter 3, we use Z is equal to X minus X bar divided by S. Okay, and they have a problem here from that. See, chapter 3, section 3, the average teacher salary in a particular state is $54,156. So that's the average, that's like the mean. So that would be like X bar, right? The mean. The standard deviation is 10,040. 10,420 actually. And they want you to find the salaries corresponding to the following Z-scores. So have part 1, part 2, part 3, and all these are Z's that are given. And they want you to find X, right? The salaries. Okay, um, so when we would, so I'm going to work out this problem, but we're going to, when we do chapter 6, section 2, we're going to be working with applications, and we're going to be using this variation of this formula also. And what I'm going to do is I'm going to actually solve this proportion for x here. So if I were to do that, I could put this over 1, and then I could cross multiply. So I could write over 1, and then I could like cross multiply. So z times sigma is z times sigma, and then you have 1 times x minus mu. Well, 1 times x minus mu is just x minus mu. And if I solve this for x, that would add mu to both sides, and this would zero out. So you have z times sigma plus mu is equal to x. Okay. And later on we'll remember this, because later on I'll bring that back in section 6.2 to, well, we're going to find z, and when we find z, we're going to plug it in, and they're going to give us a sigma, and they're going to give us a mu, and then we'll be able to define x. So just keep that in mind. Now for this formula here, if we were to solve one of these, I won't do all three, but if I were to solve one of them, I could use this variation of this formula, and I could use, let me see, to solve part 1, we could use x equal, see, x equal, and then instead of saying, I would say z, but instead of saying sigma, I could say z times s, and then plus, and then instead of saying mu, I would use x bar. And that's because this is chapter 3, but we're going to be using this later in 6.2, and we're going to be using z's and sigmas and mu's for 6.2. But for this, x is your salary, and z is 2, and s was 10,420, and you're adding the mean, which was 54,156. So then if I multiply 2 times 4,020, 2 times 10,420 is 20,840 plus 54,156. And that gives me 74,996. Okay. Okay. All right. Okay, so now we begin with, now we're going to start introducing you to the type of problems. So there's 2 mini lessons. That was just like a summary of vocabulary and things like that. Now there's 2 mini lessons. And so first we're going to find the probabilities. We're going to be finding areas underneath curves. And there's 3 scenarios, 3 types of problems that can be given. Okay. So we have on page 142, and we have on page 143 the 3 different types. So here's one type, here's 2 types. So here, this is number 1, this is the easiest type. You're finding the area to the left of the curve. Okay, and it's the easiest type because it reflects our table, the areas of our table to the left of the curve. Then we have the second type. we're trying to find the area underneath the curve, but look how it's shaded to the right of Z value, okay? And then you have the third scenario where you're trying to find the area underneath the curve and it's sandwiched, see? The area is sandwiched in between. Okay, so those are the three types of areas. Now, in your on your workbooks, they went ahead and that was nice how they put a table in there, but they put on page 143 and 144, they put both the positive tables. It would have been nice if they had given you the positive and the negative. So that positive table should be the same. It's a standard normal, and it should be the same. Like if I go 1, 2, 3, if I go down 5, 1, 2, 3, 4, 5. See 6554.6554. So I go down here 5. 1, 2, 3, 4, 5. See 6554. See how those are the same? Okay. So it's really nice how they condense this whole curve, whole table on the sheet here, and they did that nicely. But it would have been nice if they had put the positive and the negative, and they didn't do that. Okay. So that way you have another resource for the table, right? For both, but that's fine. You got the positive in there. All right. So let's give you some examples of the first scenario. So area underneath the standard normal distribution curve. So remember what we wrote earlier. Remember you wrote this earlier, this idea, you wrote this earlier here. This idea is that areas under the standard normal curve that are to the left of a z value, and this is just how I usually try to write my z's with a little line through that, are found in the table. And this is, what table is that, right? You have a lot of tables. It's in the standard normal distribution, which is table E, I believe. And different books have called it different tables names. This just happens to be table E, cumulative standard normal distribution. I just didn't put the word cumulative. Okay, so we'll do the easiest type first. So if you're trying to find the error to the left of any z value, look up the z value in the table and then use the area given. Okay, so here what's happening on this table, mu is 0, sigma is 1, and here's you're trying to find the area underneath this curve here. Here's your z value, and this, this is negative sigma. So you read graphs from left to right. So this is negative infinity, excuse me, negative infinity, all the way to this z here. Okay, so if z sits to the right of 0, that's what's happening here. Z sits to the right of 0. Then we want to look up positive side of Z scores on your table. So here we would have probability that z is less than positive z equals, and then we would get ready to look that up on our table. Okay. And so I'm going to show you an example of that. Let's see, I have a note here that page 144 would be an example of that. So let me look at 144. So let me see page 144. Example 6-1. Okay, so that's supposed to be an example of this. Okay, so if you look at it here, area underneath the curve, find the area that's to the left of z equals 2.09. So you see this is your z. Mu is 0, sigma is 1, and you're trying to find this area underneath the curve. Okay, and so when you set this up, probability stands for area. Z is less than 2.09. Okay, and then when you look this up on your table, you use the first two digits to record your Z. So you use first two numbers to record your Z. So that would be 2.0. Okay. And then you use decimal 0 with your last number. Last number is 9. Okay, so this, when you use the first two numbers to record your Z, that goes here. And when you use 0.0 with the last number, that's reflective of this. Okay, so then when you look that up, I also use two rulers. I'm looking up Z's on the positive side, so you want to make sure you don't have negatives here. Z's on the positive side, 2 point, right there, 2 point, and then 0.09. So you see all these over here, 0.00, 0.01. See how they all have zero? See, they all have 0, and then 01, 02, 03, 04. See that? So that's where I get that from. Use 0.0 with the last digit. Last digit was 9. So that would be all the way over here. And you see this number right there? That's the area underneath the curve. So if I increase this, so we said 2.0, right? 2.0 and then 0.9. And there we go. See that right there? 0.9817. 0.9817. So you want to write that down. 0.9817. And that goes to also here. 0.9817, and that goes here. And that's your area underneath the curve. So what we've done is we've looked up the area corresponding to, I can also write this down if this helps you. What we did was we looked up the area corresponding to Z is equal to 2.0 plus 0.09. Oops. In your table. Okay. Yeah, and that's because if you add that, if you add 2.0 plus 0.09, you'll get, you add those up, you get 2.09. I remember that was our Z value. Remember that was this, see, right here. So that's the easiest type when the areas are to the left of the curve. Now for the same problem where we're using the calculator, and I'm going to do I also want to do another example. That other example I'll do on the other paper though. Let's see. So, well, I guess I could do it here too. Let's see. Let me do this. So you're using the TI-84 calculator, and this is for example 6-1. So we still start off with probability Z is less than 2.09, but then here's the calculator command. Number 2, normal CDF. Oh, now I know. I wish I hadn't done that. I have to erase this. Lower bound, upper bound, mu, and sigma. So when you do your substitutions, normal CDF. So remember we read graphs from left to right. So when you read your graph from left to right, see this is all that's shaded. And you see how this is negative infinity. So this you can either use negative 10,000 or you can use negative 1 e to the 99. So you have a choice, but that's what you use to reflect negative infinity. And this is your lower bound. You read graphs from left to right, and then you stop right here, and this is your upper bound. Okay, which is this 2.09. Okay, so here lower bound is you can use negative 10,000 or you can use negative 1 e to the 99. And if you use this, then you have to use the second button and then the comma. And you would have to type in negative 1. The negative on your calculator is this key on your calculator here. So negative 1 second, and then that comma, and then 99. You have a choice. And then the upper bound is that Z value 2.09. And then remember mu is 0 and sigma is 1, which your calculator will show you that. Okay. So then when I pull that up, to get to this, remember you need to do second vars. So here's the second button, and then here's your vars. And you want C number 2. Okay, so you can tap down and hit enter. Okay, and then you have a choice. You can put either negative 10,000 and then upper is 2.09 and C mu is 0, sigma is 1. Okay, and then hit enter again. and that gives you 0.9816911644. And remember areas, this is an area. So remember you need 10 thousands. This is for area. You need 10,000. So tens, hundreds, thousands, 10,000s. And then look at the number to the right. Is that 5 or more? Yep, it's a 9. So you want to add 1 to that. So you have 0.9817. And see, doesn't that sound familiar? Doesn't that sound like what we got over here when we did our table? Okay. Now, if you wanted to use the -1 E99, you do second vars. And if you wanted to hit 2 right now, you could hit 2 instead. And see, that takes you to that. And then you would do -1. So you have to hit the negative down here, -1. And then second, and then the comma. See right here, is comma. And it only puts in one E, doesn't do EE, it only does one E, that's okay. And then 99. And then upper bound is 2.0901. And then hit enter. And hit enter again. So you see how we get the same thing? See that? Whether you use -10,000 or -1 E99. Okay. All right. These are areas underneath the curves. Now, okay, let's go back to let's go back to that page. Okay. Now, let me give you an example of this one here. This one, let me try and do it on the same paper. I think last time I did it on a separate sheet, but yeah, I guess I could do it on a separate sheet. That's fine. So, okay, here, I will say that if Z sits to the left of 0, and that's what's happening here, then you want to look up negative side of Z scores. So we have probability of Z is less than -Z equals. And then you would look that up on your table. Okay, so let me give you an example. That on a sheet of paper. Let's see. So take out another sheet of paper. And let's do C extra sheet, for example. Okay, so I'm just drawing what they had here. So let's say they were asking you to find the area to the left of z is equal to negative 1.39. So you would draw that, sketch that out, put mu in the center. And you don't have to draw this. They always draw that, but you don't have to draw that. Just mu is 0, sigma is 1. And then you could draw this though here. And your z is negative 1.39. So you see z is somewhere on this side. Here's 0, so the negatives are on this side. So just draw this line somewhere on the negative side. So here is fine. And then you're shading this to the left, And so you have probability that z is less than negative 1.39, area to the left. Okay. And then you want to look up on your table. Okay, so remember what happens. These first two numbers, negative 1.3, that's what goes here. And then see this last digit, but you have to follow it with 0.0, and then this last digit is 9. Okay, and so if I write that up the same way I wrote it up on the other page, I said that use the first two numbers to record z. Use the first two numbers to record z, so negative 1.3. And then we're going to use 0.09. Oh, I say use 0.0 with the last digit. With the last number. And that goes right here. And the last number was 9. And so when you use your table, go back, I can go back to this sheet, go back to page 144, or you can use your table. So I'll show you on this one first. Negative 1 point. Oh, I can't use this one because this have to be negatives. See, these are only positives. So I can't use this one. But you have your tables you were supposed to look up and print out. So negative 1.3. Negative 1.3, just down here. And then it was 0.09, right? Now on your paper, I don't think has little negatives. I just wrote these in a while ago. But if these z's are negative, then that means that's implied that these are also negative. So I don't know why the book doesn't do that, but I like to put negatives in on mine because if these z's are negative, this is part of z. These are also negative. And so when you have negative 1.3 and then negative 0.09, that isn't that this number right here? See that number right there? So if I increase it, looks like it's 0.0823. So there's negative 1.3. And then you go all the way up, right, to 0.09. So there it is, 0.0823 right there. Okay. See. So 0.0823. And so that means that's what this is, 0.0823. Okay. Now, if I use the calculator, this is using the table, right? This is using the table, right? And over here, when we're doing these, this was using the table. Okay, now I'm going to do the same problem, but I'm going to use the TI-84. So you start off still probably Z is less than negative 1.39. And then you want that command, because you're using second bars, to normal CDF, lower bound, upper bound, mu, and sigma. And when you do your substitutions, normal CDF, and remember we regraphed from left to right. So when you read this graph from left to right, again, this is negative infinity all the way. So this is your lower bound all the way to stops here. This is your upper bound, negative 1.39. So lower bound is, you have a choice. You can put negative 10,000, or you can do negative 1 e to 99. And then the upper bound is negative 1.39, and mu is 0, sigma is 1. Okay, so when we do that here, second vars, number 2, lower bound, I'm going to use negative 10,000. You can use either this or this, okay? And then negative 1.39, and then 0 and 1. You have this result. And then when you round to the 10,000s, because it's area under a curve, tens, hundreds, thousands, 10,000s. Look at the number to the right. Is that 5 or more? Yep, it's a 6. So add 1 to that. 0.823. And you see that should match this. See, that we got on the table. See how this matches this? Okay, that's the easiest type. Okay. Okay, now the second type, says that you're trying to find this area here, and you're trying to find the area that's to the right of any z value. So what you have to do is you have to look up a z value, and you have to subtract the area from 1. So in other words, you're using the complement idea when you're having to subtract it from 1. So here, this would say probability of z is greater than negative z. So you see, you want to find this area. So this is greater than negative z. And they're saying to use the complement. They're saying to do 1 minus, subtract the area from 1. Subtract the area from 1. So you subtract 1 minus probability of z is less than negative z. So what that's saying is you need to find this area here. in pink, and you have to take the whole unit 1, and then you have to subtract this out, and that's reflective of this. That's reflective of that when you take that out. And the reason why they use 1 is because remember the whole area underneath the curve, area under the curve is 1. So this whole area 1, take away this little piece here, will leave you with this pink region. So to see an example of that, you're going to do example 6-2 on page, let's see where that's at. I believe it's on page 145. So here's 145, 6-2. It's up here. So area underneath the curve. They want you to find the area to the right of z equals negative 1.14. So I want you to find this area here. Okay, so first we're going to use the table. Okay, so first we're going to use a table, and then we'll show you using the calculator. So you're going to start with probability that z is greater than negative 1.14. Trying to find this area, and you have to subtract 1, take away this area. So that's probability that z is less than this negative 1.14. Okay. And so then on the table, you have z. I remember the first two digits, negative 1.1. And then remember this is 0.0, and then you record the last digit, which is 4. Remember? Okay, so now when you look at that on your chart, go to your negative side of your z value and look up negative 1.1. Which is down here, negative 1.1. And then you want, and this is going to be negative 2, right? Negative 0.04. If this is negative, this is negative. So negative 1.1, and then 0, 1, 2, 3, 4 right here. So let me get my other ruler. So negative 1.1, and then this negative 0.04. And you have that value right there, which is 0.1271. 0.1271. Everybody okay with that? 0.1271. So negative 1.1 and negative 0.04. So it's 0.1271. Okay, so then that means that this is going to be 1 takeaway, and this area is 0.1271. Okay, so when we do that on the calculator, 1 take away 0.1271 is 0.8729. Okay. And if you're ever iffy about this, you can always do a little check, because if you were to add negative 1.1 plus negative 0.04, if you were to add those up, see, that gives you a negative 1.14. So you see that has to match this, see? So if you're ever iffy, you can double check that, but it matches. Okay. So this one, you have to do 1 minus. You have to start with 1 and then you're subtracting this value, okay? Um because the when you use a table, this is reflective of areas, this is reflective of an area to the left of a z value. So you need this though to the right of it. So you have to take this out, and you take it out from 1. Okay. Okay. So now to go back to, see, go back to page 140. Oh, I need to show you on the calculator how to do this on the calculator. So where can I put the calculator? Let's see. I'm going to put it up here at the top. So this is a table, and then this is the calculator. Okay, so we start off the same here, probably that z is greater than negative 1.14. So find this, z is greater than that, just the same. And then we do the calculator. So 2 normal CDF lower bound, upper bound, mu, sigma. And then you do your substitutions, normal, CDF. So lower bound, you want what's in pink. So lower bound, this is your lower bound from left to right. This is your lower bound. And then all the way to the right, this is infinity. So the lower bound for this problem is negative 1.14. And then this is infinity. So here you can use a positive 10,000, or you can use a positive 1 e to the 99. And then mu is 0 and sigma is 1. So when we do that, second vars, so remember you start off with second vars, and then number 2, and then negative 1.14, and then 10,000, and then 0, and then 1. Okay, and you get that. So this is an area to record 10,000s, tens, hundreds, thousands, 10,000s. And then you look at the number to the right. Is that 5 or more? Yes, it is. So you add 1 to it. And see how that matches this. Okay. So remember, I'm required to show you both the table method and the calculator method. And then I'm showing you both on the test. On the test, I'll ask for both. So if I ask you to demonstrate the table, then this is the work we want to see for the table. And then if I ask you to demonstrate using a calculator, this is the work we want to see for the calculator. Okay. And then on your homework, when you do your homework, they should specify too which method to use. I believe they go back and forth. They want you to use the table or the calculator. So just follow the instructions, follow directions. Okay. Now let's go back to page 142. So again, let's say we're trying to just another example to the right of any z value. And now this z is just z is on the positive side. So we start off with probability that our z is greater than, this is a positive z. So we're still going to do the complement, one takeaway. So you're trying to find this probability, which is this pink area here. So you have to do 1 minus this and take away that. So the whole area underneath the curve is 1, then you want to take this away, and all you're left with is pink. So this is expressed as probability z is less than your z here. And we're going to show an example of that. We're going to do page 45. Example 6-4C. Six dash 4C. Okay, so this one's A, this one's B, and then this is C. Yeah, and that kind of looks like that, right? That kind of mimics this, doesn't it? So you see, you're trying to find this area underneath this curve here. Okay. So this would equal, we're going to do the table first. This would be probability that z is greater than this, which is 1.98. And then we have to use a complement. The whole area underneath the curve 1 minus the probability that z is less than 1.98. So we're taking this away. Okay. And we're trying to find that pink area there. And so, and so we would use our table here. So let me see. Okay, so remember the first two digits, 1.9, go here. Now remember you always have 0.0 and then the last number, 8. And this is a positive side. You want to go to your positive side of your table, 1.9. And then it was 8. $1.9 and then 8, see? And then see that right there, 0.9761, see that? 0.9761, 0.9761. Okay, so then this is going to be 1 minus 0.9761. 1 take away 0.9761 is 0.0239. Okay, now I'm gonna do the calculator. So let me do this. Let's see. I wonder if I could squeeze the calculator down here. So the first part starts off the same. Probability Z is greater than 1.98. And remember, we're using number 2, normal, CDF, lower bound, upper bound, mu, and sigma. And then you can do your substitutions, normal, CDF. And then the lower bound, we read graphs from left to right, and you're finding this pink area. So this is your lower bound, 1.98. And then your upper bound, you read it from left to right. So you see you want infinity. So you can use either 10,000 or you can use 1e99. And then mu is 0 and sigma is 1. Okay, so then we have second vars. Second vars, number 2. And it's 1.98 for the lower bound. And the upper bound, you can use 10,000 or you can use the 1E99. So you would type in 1 and then the second and then the comma. See, and then 99. And then mu is 0 and sigma is 1. Okay. Okay, so I don't know where, can I squeeze that down here? That's 0 0.238 5, tens, hundreds, thousands, 10,000s. And then the digit by that is 1. Is that 5 or more? No. So then we'd have 0.2385. And that doesn't match. Oh, tens. Oh, I think I wrote this wrong, didn't I? Yeah, I'm missing a 0. I'm missing another 0. Okay, I'm not sure where to put that now. This doesn't fit really in here anymore. I guess I could put it over here. So So it's 0.23851. Tens, hundreds, thousands, 10,000s. Look at the right. Is that 5 or more? Yes. So add 1 to that. Zero, 2, 3, 9, right? And then see, now that does match this. Okay. So this is using the calculator. This is using the table. And you're using the complement idea. Okay. And I'm going to, while I'm at it, I'm going to do this one. This is one of the easier ones. We already covered this. This is, do you recognize this? This is the first part, the first one. There's 3 types. So this is the first part. This is an easy one. This one, you have probability Z is less than 1.73. And you just look that up on your table, right? 1.7 and then 0.03, right? One 1.7 and then 0.03. See the number right there? 9582. 9582. And then again, if we use the calculator, this is using the table. We use the calculator. But normal CDF, lower bound, upper bound, mu, and sigma, and you do your substitutions. So lower bound, negative infinity. Or you can do -1 E99. Upper bound, this is upper bound. So this is lower bound. There's mu, sigma is 1. So lower bound, -10,000 or -1 E99. And then 1.73, the upper bound. Then 0 and 1. Okay, and you're using second vars. Second vars, number 2. Lower bound is, you can use -10,000. Upper bound is 1.73, 0 and 1. Tens, hundreds, thousands, 10,000s. Then look at the number to the right. Is that 5 or more? Yep, that's an 8. So yeah, so add 1 to that. 0.9582. And you see that does match what we got on the table. Okay. Okay. So this one doesn't require the complement because this is already an area that's to the left of the curve. But this one down here that we did part C, This one requires the complement because this area that you're trying to find. So you see, the first time we were trying to find the area, it's already to the right of the curve. But this one, the area, and maybe I should have used orange on this one, maybe. Maybe I should have used orange to highlight this one because this is area to the left of the curve already. So we just had to look up that area to the left of the curve on your table. Okay, remember where this one needed the complement idea. All right. Okay, last type. There's two lessons, and in the first lesson there's 3 types. So now I need to show you the third type. And that would be on page 143. Look at this here. See these? I call these sandwiched areas, is what I call these. These are sandwiched areas. They're compound. They're areas that are stuck between 2 z values. They're trapped between 2 z values. Okay. So it says between 2 z values, you look up both z values on your, like on your table, and then you want to subtract the corresponding areas. And when you do that, there is an order to that. You should be subtracting the larger area minus the smaller area under your curve. Okay, so like here, the way we would kind of set this up, this generic setup, you have probability and you write an inequality, a compound inequality. So you would write like a compound inequality. So it was trapped. So write it kind of like this. See that? Your Z is trapped. You're trying to find an area is trapped between the negative Z and the Z. Compound inequality. And then you do the larger one. Okay, so this is the larger area, this right here. When you find, this would be your larger area. So like you're finding all of this here, this, all of that is that larger area. And then you're taking away the smaller area. So then you're taking away this smaller area. Okay. So then the way this would work, like this generic setup, you would have probability and it's trapped between Z sub 1 and Z sub 2. So again, it's trapped between Z sub 1 and Z sub 2. So you do the larger area with the less than Z sub 2 minus the smaller area. So this is the larger minus the smaller. Okay. So that's for this one. Okay, now try to set up this one. This, can you write this out? So pause the video, and then try and set this generic one up right here. Okay, so let's see. Did you write this? Let's see. Probability z is trapped between negative z sub 1 and negative z sub 2. And you're going to do the larger area, probability of negative z sub 2 minus probability of negative z sub 1. So the larger area minus the smaller area. Okay, so that's the general gist of that. Okay, now let's see. We're gonna do the remaining. I think these remaining 2 examples. See, this is it's trapped. See, this is trapped. So let's see. This. Let me see which one. So I know you have 3 different scenarios. So that we got 2 of the 3. So let's see which ones we have. It looks like. It looks like to show you kind of an example of this one. I mean, they're all subtraction, the larger area minus the smaller, but it looks like this one you would do, example 6.3 from page 145. And then well, this other one doesn't really fit. I mean, the second one it's trapped, but it doesn't really fit. I mean, it does fit these, but it doesn't fit these more specifically, if that makes any sense. So that's fine. But we're going to do example 6.3, and we're also going to do example 6.4a also. And those fall, uh, that's on page 145. And those 2 are going to be the 2 examples of this. Okay. All right. So let's go to page 145 and show you that. Okay, so we start with this one here. Area underneath the curve. Find the area between z equals 1.62 and z equals negative. Oh, there should be a decimal here, right? Negative 1 point. There's a typo. Negative 1.35. Yeah, okay. All right, so you start off with, we're going to do the table first, and then we'll do the calculator. Okay, so both of them you start off with probability, and this area is trapped. So you have to show that it's in a compound inequality. It's trapped between the both. So you put the lower one, the smaller one first, negative 1.35, the smaller z value, and that it's trapped between negative 1.35 and 1.62. So both of them, whether you do it on the table or on the calculator, they both start off like that. Okay. Okay, then, and let me come back this way because I want to do the calculator on this side. I want to do the TI-84 calculator on this side. Okay, so then now I want to do the larger area, take away minus the larger area minus the smaller area. Okay, so when we do that, we set it up this way. Probability Z is less than. So the larger area is all of this, so less than 1.62. And then you're taking away the probability that Z is less than this little area, negative 1.35. And then we're going to use our table. So then our table would show this. So this is 1.6 and then 0.02. And then we're going to subtract the other table. You're going to subtract the other table. The other table we're going to look up is negative 1.3 and then 0.05. Okay. So the first, we have the larger ones of the positive 1.6 and then 0.02. Okay, see that number right there? Okay, see that right there? So it's 0.9474. 0.9474. Okay, now we're going to do the negative, this negative 1.3, 0.05. Negative 1.3. Negative 1.3, 0.05. Okay, see that number right there? See that number? 0.0885. 0.0885. So see negative 1.3, negative 0.05. 0.8, no, 0.0885. Okay. All right, so that means then we're subtracting those areas. 0.9474 minus 0.0885. Okay. All right, so 0.9474 minus 0.0885 is 0.8589. Okay. Okay, so that's finding this area here. Okay, now we're going to find the area again using the calculator. So this will be set up the same. Your area is trap, between negative 1.35 and 1.62. And we're using that number 2 command, normal CDF, lower bound, upper bound, mu and sigma. And we're going to do our substitutions, which is normal CDF. Okay, and we read graphs from left to right. So this is your lower bound, and then this is your upper bound. So this one doesn't have any infinities. No, you don't always have an infinity. This is your lower bound, which is the negative 1.35. And then this is the upper bound, which is the 1.62. And mu is 0 and sigma is 1. Okay, so lower bound, upper bound. Okay, so then I do second vars. Second vars, number 2. And lower bound is negative 1.35. Upper bound is 1.62. 0 and 1. Okay. And then I'm going to round this in there's 10,000s, tens, hundreds, thousands, 10,000s. And look at the neighbor. Is that 5 or more? Yep, it's a 7. So add 1 to that. So 0.8589. And that should match this the way we got it on the table. Okay. Okay, so there's one more to show you that's showing you that you're going to subtract the area. So larger minus the smaller. Okay. Okay, so where do I put that? Let's see. Okay, you think I'll squeeze it here? Okay, so we do it on the table first. So we have probability that Z is trapped between 0 and 2.53. Okay, then that's equal to the larger area. Z is less than 2.53. Take away the smaller area. Z is less than 0. Then we look these up on their respective tables. Okay, so this is going to be 2.5 and then 0.03. This is going to be 0.0 and then 0.00 because this is 0. Okay. Okay, now when I look those up on the table, 2.5 2.5 3. See that number right there? That'd be that number right there. See that? 0.9943, 0.9943. So you see 2.5 and 0.03, 0.9943. Okay, and the other one was 0 and then 0, Z0, 0. And see the value of that is 0.5. See that? 0.5. Yeah. And so you see, the whole area underneath the curve is 1. So you see when you go from 0, this is 0.5, all the way to this side, see, that's almost 1, 0.9998. That's pretty close to 1. And when you do the negative side of your table, you look at your negatives. See, this starts off, this is almost 0 here, 0.0003. That's almost 0. And then it goes all the way to this value. See that? That's pretty close to 0.5. 0.4641 is pretty close to 0.5. So, the whole area underneath the curve is 1. And so, like, the whole area underneath the curve is 1. Then this side is 0.5. And then this side is 0.5. So that's reflective on your table. Okay. Negative side, positive side. Okay. So then what we have here is 0.9943 minus 0.5. 0.9943 minus 0.5. 0.4943. Okay. And then if I squeeze the calculator, TI-84 here, this will be the same, that you're probably is trapped between 0 and 2.53. And we're using number 2 normal CDF, lower bound, upper bound, mu, and sigma. So again, you read graphs from left to right. So this is your lower bound, 0, and then this is your upper bound, 2.53, and then mu is 0, sigma's 1. So there's no infinities here, and there's not always an infinity. Okay, these have beginning and end. Okay, so then you use your calculator. Second bars. Number 2, lower bound is 0. Upper bound is 2.5301. Okay. Four, 9, 4, 2. So tens, hundreds, thousands, 10,000s. Then you look at the number to the right. Is that 5 or more? Yep, it's a 9. So add 1 to that. So that should be 0.4943. And that does seem to match this then. Okay, so I'm required to show you both the table and the calculator. And you can see in the workbook that the workbook, when it explains it seems to just talk about only the tables, right? It talks about the tables, how you subtract. But um, but there is a calculator alert here. So, you know, so here they talk about like you're using the tables, right? Reference, we're using the tables. But then they do say something about a calculator alert. So I'm sure this link is still a good link. You could, if you wanted to see the calculator from a different perspective, I'm sure that link is still good. You could look that up. Okay, but I'm required to show you both the table and the calculator. And then on the test, I mean, if you have time, you could check it doing it both ways if you have time, but I will require one and I'll just let you know in advance what steps I want to see. But yes, you want to circle the right answer, but remember to get the full credit, you have to show your work the way we're showing you here. So if you're doing the calculator, you set up your probability, you do your formula, write your formula, you do your substitutions, and then you get this from the calculator. If you're doing the table, you still set up, introduce your probability, and we did that on test two. You have to introduce your probability. So you introduce your probability, and then this requires on the table subtraction. So you set that up. You're doing the lower, I mean the larger area minus the smaller, and then you look it up on your table, then subtract. Okay, so you want the points and you have to do it the way we're showing you because we're spending all this time recording showing you how to do this. Okay. Okay, now there is a second part of the lesson. Let me go ahead and do that because I'm not yawning. Sometimes I'm sorry if I've fallen asleep on some of the other videos. Good, too much to do, but I'm actually not sleepy, so I'm going to keep going and finish this video for this second part. But if you want to take a break, you can. You just record it. But what we're doing now is, and you definitely should take a break. Definitely should take a break, sit down, drink water, take a break, and then come back. But now there's a second part of the lesson, and the second part of the lesson is now we're going to be given areas underneath the curve. So we're going to be given probabilities. We're going to be given areas underneath the curve. And then they want us to find the z value. So you see, these are areas underneath the curve, and they want us to find z. Areas under the curve, they want us to find z. Okay. All right. So the way that would work is well, the first one is the easiest type because this is already an area to the left of the curve. That's what makes it easy. So I'm going to write that down. This is an area that is already to the left of a z value. So we're going to use this area to locate it in the table. Okay. And we're on the negative side. On the negative side of z. So you see how z is on the negative side? So when we're looking this up on our table, we want to be looking up this area. This area is 0.0188. Okay, so we know we're on the negative side of z. On the negative side of z. Okay. And we want to look up 0.0188. So if I start, you want the area underneath the curve. See, these are all areas underneath the curve. Okay, so I want, this is 0.0003, and you're trying to look this up. You're trying, it's like almost like you're looking for a needle in the haystack, right? You're looking for 0.0188, but there is some order to this. So you see these areas are increasing as you move along. So 0.01. So let me look for 0.01. Okay, here's 0.01. 0.01. You want 0.0188. Okay, so you see here's 0.017, and then see, so maybe it's along this way. 0.188. Okay, let's see. See that right there? 0.188. Okay, so you see this negative 2.0, and then you see this over here. See this negative 0.08. That's what you want to capture. So you have negative 2.0 here. And then you have negative 0.08. Okay. And so when you find your z and you add those up, you're adding negative 2.0 plus, you're adding negative 2.0 plus a negative 0.08. So when you add those up, that's your z. Your z is equal to negative 2.08. That's your z. That's your answer. Okay. Now, on the calculator, the command, the calculate, this requires a new command. So on the TI-84, you need this command. Z is equal to number 3. So we're still doing a second vars, but now we're doing a number 3, and we're doing an inverse norm, and that is area, but the area has to be, when you put in these numbers in here for the area, you have to make sure that this area is of reflective reflective of an area that is to the left of a z value. So area mu and then sigma. And in this section 6.1, mu is still 0 and sigma is 1. It's in section 6.2 where they're going to start assigning different values to mu and sigma. Okay, so this is an area to the left. See, this is an area to the left. So we can use that here. So now you do your substitutions. So this is z equals. So you put inverse norm, and area is 0.0188. Mu is 0 and sigma is 1. So you do second inverse second, excuse me, second bars. And then you want number 3, number 3. Not number 2 like we were doing earlier, but number 3. And then the area is the area to the left, 0.0188, and then 0 and 1. Okay, so it's negative 2.079188807. So, oh, now remember here, areas are 10,000s. This is a z-score. Remember what we wrote on our paper? Areas are recorded to 10,000s, but this is not an area now. This is a z-score. Z-scores are recorded to the hundredths place. Tenths, hundredths. Okay, and then look at the right. Is that neighbor 5 or more? Yep, that's a 9, so add 1 to that. So negative 2.08. Okay. Okay. All right. Okay, now. Whoops. Oops, 45. Okay, so let's see. All right, 45. Here's 45. So this is for number 43. All right. Okay, now see how this is not an area that's to the left of the curve? You need to be looking up the area to the left of the curve, especially when we're using the table. Okay, now remember the whole area underneath the curve is 1. Okay, so what we're going to do to find this value is we're going to use the complement and we're going to subtract. So we're going to do 1, take away this 0.8962. And 1 take away 0.8962 is 0.1038. And that's this area here. 0.1038 is that area there. Okay. All right. So when I'm looking at my table, and I'm trying to look that up, trying to find my z, I'm using this area 0.1038. That's what I'm using. So I have to use the area to the left of z. See that? I cannot use this one. I have to use this one. And the best thing to do is do 1, the whole thing 1, because the whole area underneath the curve, that area is 1. So you do 1, take away all this, and you're left with this little piece here. So when you look that up, you can see you're on the negative side. So you're on the negative side of z. So you know to go to the table that's got the negatives, and you're looking for 0.1038. So and always start from the top. 0.10. 0.10. Okay, so here we go. 0.11. So back up. Okay, here we go. See some 0.10s. 0.1038. There it is right there. See that? There it is. Point 1038. Point 1038. And then see that and that. Okay, so I need to capture those, okay? Okay, so it is negative 1.2. And then negative 0.06. Okay. All right, so that's my Z. So that would be, right, sum those up. Let's see. I'm going to add a negative 1.2 plus a negative 0.06. So that's 6, and that's 2, and that's 1, that's negative. And that's what my Z is. That's what my Z is for number 45. And that's using the table. Okay. Okay, now we're going to use the calculator. TI-84. Okay, so this is where you use 3 inverse norm area mu sigma. Inverse norm. Now remember, the area has to be area to the, remember, area is got to be to the left of Z. So don't use this one. Don't use that one. Use this one. Zero and 1. So second bars, number 3, 0.103801, negative 1.260. Remember, Z's are hundreds place value. It's not an area underneath the curve. It's a Z-score. So tenths, hundredths. And then look at the number to the right. Is that 5 or more? Nope. So it's going to stay negative 1.26. You see, the same thing. Okay, now on 41, you want the area to the right, area to the left of your Z. You want this area here. Okay, but instead of doing 1 minus, you can do 0.5 minus that, because you know half of your curved or symmetry, half of that is 0.5, like 50 cents. So instead of doing kind of similar idea, like here, 1 minus that, we did 1 minus 0.8 a while ago here, 0.89. You're going to do something similar. You're going to do 0.5 minus this, which is 0.4175. So 0.5 minus 0.4175 is 0.0825. And that's what goes here. That's that area there. 0.0825. So I got to find that area on my table. So I'm trying to find now. Okay, now look, I already know, I know already this this is related to the need for this last part of the lesson. I asked you to print this extra sheet out. So I already know this is sometimes an area is going to be in between. You can't identify it specifically. It's trapped, it's in between a couple of areas. And so that's why I'm making this longer. And we're trying to look for 0.0825. Okay, and again, we happen to be on the negative side of Z. Okay, and this is predominantly what's going to happen in the next section, section 6.2, when you're working with applications and story problems. In reality, you can't really find it exactly on the table. It's in between two areas. So this is predominantly what you're going to see in the next section. So we're going to try and look up 0.0825 as best we can. Okay, so we're on the negative side of Z, 0.08. Okay, 0.08. Okay, so 0.06. Okay, here you go, 0.08. And you want 0.0825. Okay, so I went down to 0.7. Okay, let's see. 0.08. What was it? 225, right? It looks like it gets pretty close. Doesn't it look like it gets pretty close to that? Because see, here's 0.0823. See, here's 0.0838. So this would be 0.8. They're both 0.8. This would be 23, and then this would be 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, and then 0.0837, and then 0.0838, right? So it falls in here. So this is what I mean, that it falls in between two other areas on the curve. So I need the negative 1.3, and then I need this top part. So I need the negative 1.3, and I also need to record both of these. And then I need to record these. Okay, so on my chart here, I'm going to start with the negative 1.3 right here. Right. And then the 0.0825 is somewhere in between these two. So I'm going to put what does that say there? 0.0838. And then 0.0823. So 38 and 23. Okay, now I want to grab these top parts. Remember, Okay, so let me go back. See what were they? So let's go back over here. Mm. See that? Negative 0.08, negative 0.09. See that? Okay, so everybody got that? Okay. All right. So then let's take a look at this. Okay. So we've got to make a decision. Do we go here or here? We got to just find out what Z is. So we're like, do I go with the Z negative 1.38 or do I go with the Z negative 1.39? Those are your two choices. And that's why we have this lesson to do, because this tells you what to do. There's two scenarios that can happen, and here are the rules to follow for that. Okay. But in the meantime, before we show you that on the table, we also know how to do it on the calculator. So right now we're gonna use the calculator. And we're gonna do Z equals number 3 inverse norm area mu sigma. And remember we said area, we said to the left of Z. So remember, do not use this one. You got to use this one. So this one we did subtraction and we didn't do 1 minus on this one. We did 0.5. See, it's half the chart. Over here we did 1 minus this. Here it's 0.5 minus this. And that gave us 0.0825. Mu is 0, sigma is 1. That's second bars, number 3, and it's 0.0825. 0 and 1. And we get, so they will go with, let's see, negative 1 Z equals negative 1.38845. Okay, so they went, we're going to round to nearest 100. This is a Z score. So Z score, you round to nearest hundreds, tenths, hundreds. Then look at the number to the right. Is that 5 or more? Yep, that's an 8. So you're going to add 1 to it. So that's about negative 1.39. Okay. So they went with the calculator went with the negative 1.39. See, so we knew it was between these two, and the calculator went with that. Okay. And I mean, sometimes there's a variation. This example, very last example on this page that I'm going to show you, there's a little bit of a discrepancy on that, but for the most part, they agree, the table and that agree for the most part. Okay, so now I'm going to show you when you're doing the table, how do you know what to go with? Which one do you go with? So I'm going to show you that. So this would be the last two. This is it. This is the page, and we'll be done. Okay, so this is one of those pages I asked you to print out for this lesson in addition to the workbook. So when finding a z-value that corresponds to an area in the cumulative standard normal distribution table, if the specific value cannot be found, they want you to use the closest value. They want the z-score that relates to the smaller distance. And if you have to take a physics class or chemistry class, you do some of that. When you find distances, you subtract and you do absolute values. Okay, and so area minus potential is what I'm calling this. Um, and so um, here's an example that I'm going to use because when we do 6.2, it's applications. The very first problem is dealing with this desired area of 0.9, which is like 90%. So you know the whole area underneath the curve is 1 or 100%. And so 90%, 0.9, so almost the whole graph is covered. So this is right here, this is a value of 0.9000, right? And which is the same as negative, which is the same as, excuse me, 0.9. This is your area underneath your curve, okay? And sigma is 1 and mu is 0. And you're trying to find your z. So you're trying to look for this in the table, you're trying to look for 0.9, and then these are all zeros. Okay, now this time we're on the positive side of z. See, usually we're on this side, the negative side. This time we're on the positive side. So we're on the positive side of z. So you want to be careful with your chart when you look those up. And you're looking for area equals 0.9. Okay, so here's 0.5. 0.8, you're looking for 0.9. Okay, here's some 0.9s. You were looking for 0.9000. So actually we're over here then, right? See, so you're like 0.9000. It's like in between here. Yeah, you're in between these two over here. This right here, see? So I'm going to record the 1.2. Maybe I should put this here. Maybe that might help. So I'm looking at these right here. So I'm going to record the 1.2. And I'm going to record this 0.8997. And that's related to 0.08. And then I'm going to record 0.9015. And that's related to 0.09. And then I'm gonna try and find I need to find the distances. So the idea is you do your area, which is 0.9, absolute value of 0.9. And you're going to subtract the potentials. So you're going to do 2 subtraction problems. So it doesn't matter which one you do first. I'll do this one first, 0.8997. And then I'll subtract this one, 0.9015. Okay, so I'm doing the area minus the potentials. And I'm going to subtract. Now it's actually easier, and you can have 2 calculators out for this one. If you have a basic calculator, it's actually easier to do the basic calculator. 0.9, 1, 2, 3 zeros minus 0.8997. Here's your distance. Because this one does scientific notation. 0.9000 minus 0.8997 gives you that scientific notation. So that is 3 e to the negative fourth is 3 times 10 to the negative fourth, which means you want to move this to the left 4 times. So that means this counts as 1 move, and then you have 3 zeros, and then the 3. And you see that we just got that here, see? So it might be easier for this test to have 2 calculators out, and that would be a little bit faster for you. But otherwise, this is what this has, and you just scientific notation, you get that. Okay, then this is 0.9. This can be just 0.9 because these are all zeros. Minus 0.9015. And I think sometimes you'll get the same thing here on this one. 0.9 minus 0.9015. See? And you want to take the absolute value of that. So the absolute value of negative 0.0015 is 0.0015. And then when you compare each place value. So you look at the tenths place. And they're tied. Well, and even if you look at the ones place, they're tied. Look at the tenths place, they're tied. Hundreds place, they're tied. It's not till you get to the thousands place. Get to the thousands place, this is a 1. This is a 0. So 0 is smaller than 1. So this is a 1, this is a 0. 0 is smaller than 1. And so this is the smaller one. Okay, so then when you backtrack, if that's the smaller one, then you go back to that potential area. Then that takes you back to this. And then that takes you back to that z value. So you see, you're between this z value or this z value. So you're like, which one do you use? So just use the one with the smaller distance. So you're doing 1.2 plus 0.08, and 1.2 plus 0.08 is 1.28. And that's your z. Trying to find your z value. Okay, so when I lecture over the 6.2 in the first application that we do, I believe on that problem, we're trying to find x, and the formula z, let me see and go back to that. on that one. Let me see. When we do that, we're gonna relate to this. We're gonna try to find x, but before we find x, we need to find z. And in that problem, the area is 90% or 0.9, and the z will be 1.28. So then I'll save time. I'll say, remember this problem, we found z for this area to be 1.28. So we'll just plug in 1.28, and then they're going to give us a sigma. They're going to give us a mu. It won't be 0 and 1. They're going to give us a sigma and mu, and then we'll find x. That's going to be part of our work in the next section, okay, leading up to the next section. Okay, so that's the idea. So I think that's the case that's going to happen back on this problem. We go back to this one. Go back to page 146. Okay. So do we go with negative 1.38 or negative 1.39? So we did the calculator right away, but to do it on the table, you would find the smaller distance. That's one of the scenarios. There's two scenarios that can happen. So this is reflective of the first scenario where you're trying to find the distance, the smaller distance. So when you subtract, it's the area, which is 0.0825, and you do the absolute value, and you're subtracting both of these potentials. So it doesn't matter which one you do first. This one, and then let me do the other one over here. 0.0825 minus 0.0823. And so I'm going to use this calculator thing. It's easier if you do a basic calculator. So 0.0825 minus 0.0838 is a negative 0.0013, which is just 0.0013. Now if I do it on the graphing calculator, point 0.0825 minus 0.0838. Okay, that gave us this. Well, gave us the negative, yeah, and then we took the absolute value. So yeah, sometimes it's the same. It doesn't always give you a scientific value. Okay, this one is now 0.0825 minus 0.0823, which is 0.0002. Let me do that on this calculator here. 0.0825 minus 0.0823. See how that gives you scientific notation? That would be in case you don't have another calculator and you have to learn this one scientific notation. That's 2e to the negative 4, which is 2 times 10 to the negative 4. And that means you want to, your decimal is right here. That means you want to move it to the left 4 times, and that counts as one move. And then you need 3 zeros. Okay, so you move back this way. Okay, and you get that, right? Okay, so it is easier if you have a little basic scientific calculator. You can use 2 calculators for this test. Okay, now when I compare the place values, the tenths place are the same. Hundreds are the same. Thousands, okay, they beg to differ. So this one is a 0, where this one is a 1. This one is smaller. This is the smaller distance. 0 is smaller than 1. Okay, so then you backtrack to the um, um, potential area, right? So how did I do that on the other one? Let me go back to the sheet. Yeah, so when this one was the smaller, we backtracked to the potential area. We went back to the potential and got the Z. So we want to do the same thing here. So here you backtrack to the potential and then you backtrack over here to the C, this one, potential. And then that gives you this part right here. So smaller, backtrack, potential, in the table, you go. So you're going to go with the negative 1.39. So Z is negative 1.39. And that's what the so sometimes the calculator varies off by a digit. Like the calculator will say like negative 1.38 sometimes. And that's going to happen on the last example. Every now and then they vary. So that's why you want to be careful. Like if they tell you to use a calculator, then use a calculator. If they tell you to use the table, use the table, because sometimes they can vary. And that's why you want to make sure you use what they're asking you to use, because that's how they're relating to the answer. But for us here, the Z, is negative 1.39. And we get that on both the table and the calculator here. Okay. Okay, so now the last example, this is the last one for the lesson. Sometimes when you're finding the area, like here you're finding the area, this is 95% or 0.9500. So the whole area underneath the curve is 100%. Sigma is 1, mu is 0. Sometimes if the specific value cannot be found, but it falls exactly halfway between the two Z values, what does that mean? Meaning that the distances are actually tied, meaning that these distances are the same, they're actually tied, they're equal. Then your instructions for Z, then they say Z is halfway between the corresponding Z values. And what that means is you want to take the average, add them up, and divide by 2. Recall Z values are recorded to the hundredths place value. So here we're trying to find the area 0.9500. And we know we're on the positive side of Z. So we're positive side of Z, and we're trying to find 0.95. Okay, 9500. So we probably want to go up here, 95. So probably like right around here, 9500. So we actually want in here, right? Because this would go over. This would be 505, 506, 507. This gets larger. So you want did you want like 0.95, which would be here, 95, 9501, 9502, 9503, 9504, 9505. So 0.95 is here. And then go back up here. Okay. So then we want to record these two. And then it's in between these two potential areas. And then here's your 1.6. Okay, so I'm going to record that 1.6. And then it's between 9495 9495 was 0.04. And then 0.905, 9505, sorry, right? And then 0.05. Oops, let me scoot this down. Okay, is that right? Okay, so I hope you agree with that. We're saying that 0.95 would fall in between these two areas. So I grab that part of the Z in both of these, that Z. All right, so then now, let's see. So now we're going to subtract these areas. And this is supposed to be an example where they're going to be tied. So let's show you that. So you do the area, which is 0.9500, or you can just say 0.95, and you're going to subtract both the potential areas. And it doesn't matter which one you do first. Okay. And then it is easier if you do a basic calculator, because sometimes the graphing calculator does scientific notation. Because that's the negative. But remember, you're taking the absolute value. So the absolute value of a real number is just its positive. Yeah, and you see how these are identical? See that? Okay, now I'll use a graphing calculator and I'm going to subtract the top part. Let me see. I just want to see if I get the scientific notation. See this one? When I use my graphing calculator, I get the scientific notation for the first one. So this gives me, I don't know where to put it. This gives me 5e to the negative fourth, which is 5 times 10 to the negative fourth. And this means that you just move it to the left 4 times. So this counts as one move, and then you have 3 zeros. Okay, let me do the other one. I'm going to do this subtraction now. That one also gave me, see, scientific notation, and it's a negative. Which is just, 5 e the negative 4. So this is absolute value of the negative, which is just this. Now this is still here, but this negative here is gone. And then that's 5 times 10 to negative 4th. You're going to move it to the left. The decimal's here. So it's 1, 2, 3, and then that counts as a move. But you still see that they're equal. They're equal distances, and that's what this is saying. So since the distances are equal, then find z value by taking the average of the two z values. Okay, so then we would do the 1.64 plus 1.65 and then divide that by 2. Okay, so you would do, so you want to use your calculator for that, parenthesis 1.64 plus 1.65 in parentheses divided by 2. And that gives you 1.645. And then this is a z-score. So if you round this to the nearest hundredths, tenths, hundredths, when you look at the number to the right, is that 5 or more? Yep. So you add 1 to it. Then you have 1.65. And that's using the table. Now, this is the one where there's a discrepancy now, but this one, this is like an important value, 0.95. This is one of my favorite tables here that I like to use. See how it tells you area C 0.95. That's an important area they like to sometimes identify separately on their tables. But see how it says z-score is 1.645, and that's what we got here, see? But then we rounded it to the nearest hundredths. So that's why we got 1.65. Now, you know, when we do this on the calculator, when I check it on the calculator, let me do this at the top and I check it on the calculator the way we did this, remember the inverse norm, and we do our area. So let me show you that, because that one's where it differs a little bit. So if I do that for this one, z is equal to 3 inverse norm area mu and sigma. So z equals, and I'm going to do my substitutions, inverse norm. And remember, your area has to be area to the left of z, remember? So when you do your area to the left of z, we're talking about this, right? You're looking for 0.9, right? So remember we were look for area 0.95. Remember, that's what we're looking for. So it's to the left of the curve. So when I put that in, and this is mu is 0, sigma is 1. So I have second vars, number 3, 0.9501 1.6448 5, 3, 6, 2, 6. So you see how it's going to be a little bit off because when we round this to the nearest hundreds, tens, hundreds, and then is this neighbor 5 or more? No. So we have 1.64. So you see here how the calculator gives you one decimal place off, whereas our table, we did our table, or doing the average, our table went with 1.65. So that's what I mean, that sometimes there's a subtle differences. So if they say do this problem using the table, then you best do that. If they say do this problem using the calculator, then you best do that. That way, if there is that subtle offness, then you won't get it wrong because it'll match. Okay, so that's why there's another reason why I have to show you both methods. Okay, now this one, sometimes you don't get any discrepancy. Like when we did this one on the table, we both got negative 1.39 on the calculator and even on the table with the smaller distance. So like this one, if I go back and do this one, we did it with the table, we found the smaller distance. So we went with 1.28. And then if I do the calculator for that and the areas to the left, area is 0.9. I'm going to do my substitutions. And as we said, area is 0.9, and you don't need to write all those zeros. Mu is 0 and sigma is 1. So that I will write. And then when you're using your calculator, it's the second bars. Second bars, number 3, 0.9, 0, and 1. Okay, it's already there. And then you round to the nearest hundredths. You look at the right, is that 5 or more? Nope, it's a 1. So Z is about 1.28. And you see that one matches, right? That one matches, right? Do you remember see how in purple we went? So most of the time they do match, but when you have those subtle offness, and you just why if you get it wrong, did you follow the directions with how they wanted you to use? All right. Okay, that was a long section. All right, so good luck with your homework then. Okay, take care.